just spotlight Brother Shakeel for everyone, and then he will begin tonight's presentation. So Brother Shakeel, please take it away.
Jazakallah, Riyad, Brother Riyad. Assalamu alaikum wa rahmatullahi wa barakatuh. Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul uqdatan min lisani yafqahu qawli. Jazakallah for the great intro. As Brother Riyad mentioned, I have been friends with him since high school. And he's one of the most kindest and most generous people that I've ever met, and quick to smile. And as a Canadian, I could tell you he's one of our best exports to the US, tariff-free as well. So let's not go there a bit further. So let's get started then. Tonight's topic is Islamic heritage in astronomy. And also we'll be touching upon the uncontroversial topic of moon sighting. So let me share my screen. We can get started. Okay, Bismillah. So today's agenda, as I mentioned, a brief introduction about myself, who I am and how I'm involved in astronomy. Then we'll get into the Islamic contributions to astronomy, and we'll talk about Quranic references, and there are a plethora of those. And then we'll talk about two main astronomers, two of the famous astronomers that were Muslim and had a profound impact on astronomy from an Islamic perspective, Al-Sufi and Al-Biruni. Then we'll talk about the dynamics and the mechanics of moon sighting, and we'll talk about both aspects, both from a calculations perspective and from a moon sighting perspective. And the key here is that I'm not going to advocate one or the other, but it's very important that we as Muslims understand what we are actually following, one or the other. If you are following calculations, you know what that means. And if you're following moon sighting or hilal sighting, you know what that means as well and what the parameters are for both. Then we'll go into what you can currently see in the sky. And I've actually done this from a perspective of Cooper City in Florida, but it applies to any part in North America as well. And then at the end, we'll have some time for some Q&A. So Bismillah. So a bit about me. Who am I and how am I involved in astronomy? So I've been interested in astronomy since my early teens. And I was given a hand-me-down telescope. It was barely functional, couldn't really focus properly. But with it, I was able to see sunspots from my bedroom. It had a special filter at the end. And from that, I could actually see these spots on the sun, which as a 12 or 13-year-old, it blew my mind that I could see something from my bedroom, which was 93 million miles away. So as I grew up, and got my own money, I started to buy my own equipment, and I bought several telescopes, which I own today, and I got into astrophotography. And astrophotography is a variety of fields. So astrophotography is taking pictures of the stars in the universe and the planets around us. But there's landscape astrophotography, there's planetary astrophotography, and then there's wide field in terms of nebula and whatnot that you can take pictures of as well. Each one requires different equipment, and each one requires different cameras and different techniques. So then I became a member of the Royal Astronomical Society of Canada, and I have been for about 20 years or so. And alhamdulillah, some of my pictures have been featured on Cross Canada publications, and just recently it was featured on the Cross Canada RAS calendar. I've won about 11 awards locally, and the highlight of that was last year where I won first place in the solar system category in Starfest. And Starfest is the largest astronomical gathering in Canada and one of the top 10 gatherings in the world. So alhamdulillah, all success is from Allah, and I hope to continue my success in astronomy going forward. I do have social media channels where I post my latest pictures. The masjid is actually connected with me on Instagram, which is at Unshackable Astro. YouTube, I have several videos of the Milky Way and the planets as they move across the sky. And I'm also available on Unshackable Astro Photo on Facebook. Just to highlight a couple of the pictures, this was the Starfest winning picture from last year. And the reason this was the winning picture is because it highlights both of the largest planets in our solar system, Saturn with its beautiful ring system and Jupiter with its cloud belts. And here you can see the volcanic moon Io casting its shadow on the surface, on the cloud tops of Jupiter. Jupiter can fit 1,300 Earths inside here. And this great red spot here has been spinning for at least 450 years. And this is the size currently of about 1.5 Earths. And on Saturn, this moon here, Tethys, was casting its shadow directly onto the clouds right behind Saturn. And you can see several of the other moons of Saturn as well. And more recently, I took this picture of the International Space Station crossing the surface of the sun. And this was featured on Astronomy Magazine's Picture of the Day. So a little, again, this, as I mentioned earlier, there's a difference in terms of the equipment that you use in photography. The telescope that I used for the previous picture was completely different than the one that I used for this picture. And in this picture, this whole sequence of the space station crossing the sun, it occurred within about half a second. So you need a very fast camera to catch this. You need a very specialized telescope to capture these features on the sun. So just going to highlight what the type of photography that you can do, and not from an observatory, but from your backyard or from someplace out in the wilderness as well. This also shows some prominences as well at the edges of the sun. So getting into our main-ish topic is Islamic heritage in astronomy. So in Islam, there's a great emphasis on seeking beneficial knowledge, of learning, teaching, and reflecting. The Quran always tells us to reflect upon the signs of Allah. And in the universe, there are, as I mentioned, a plethora of signs that are littered throughout the universe that you can just look at even a few of them and reflect about the creation of Allah and the might of the Creator. The Islamic Golden Age, where Muslims really shone in the astronomical field and in the sciences field, generally occurred between the 8th to the 16th centuries. And this was a time of enormous advancement in multiple sciences, including math, art, architecture, pharmacology, medicines, and science. In astronomy, what happened was the focus on astronomy led to the building of massive observatories, some of which stand today. There's one in Uzbekistan by the ruler Ulu Bek, which most of it is preserved. And also advanced models of planetary motion and tools such as the astrolabe were refined and perfected during this time period. And one of the testaments of this is that at least 210 of the most easily visible stars in the sky have Arabic names or names derived from Arabic words. And about 52%, about half of them, just over half, come from actual or authentic Arabic names, while the rest are from Greek original names, so they're Arabized names. The Muslims basically took the learnings from the Greeks and took them to the next level in terms of the advancements, fixing the issues and the errors that were made by the Greek astronomers, and really laid the foundation for the new for the discoveries that came afterwards. So in the Quran, there are many references, as I mentioned. So in these two verses, the first one refers to the creation of the universe. So Allah says, the heavens and the earth were once one mass, and we split them apart. And the latest theories in cosmology shows that this is exactly how the universe, we believe now, started with the Big Bang, which probably most of you have heard about. The Big Bang, everything was joined together, and as we know, Allah said kun fayakun, and it expanded in all areas, and it's still expanding. And this took place billions and billions of years ago, and we can't fully explain why it's actually accelerating in its expansion, because normally what you have an explosion, the acceleration is at the initial portion of the explosion, and things slow down. But for some reason, and astronomers have thought that this is maybe due to some matter called dark energy or dark matter, it is actually expanding at the edges. So this one, the scholars say this references the Big Bang. And the second one here refers to Allah saying, then he turned towards the heaven when it was still like smoke, saying to it and to the earth, submit willingly or unwillingly. They both responded, we submit willingly. Now, some scholars have said this also refers to the creation of the universe, the Big Bang. But those of us that are more attuned with astronomy look at the subtle differences here. And my perspective from what I've seen is that this actually refers to the creation of the solar system, our solar system. Because The solar system actually started with a massive cloud of what looked like smoke, which is dust and gas, and it began to spin. And as it spun, it flattened out, and the material fell towards the center and ignited, causing the formation of the sun. And then the planets formed around it as well. So there is a subtle difference between these two ayat. Then we get into planetary motion, and Allah says, "It is not for the sun to catch up with the moon, nor does the night outrun the day. Each is traveling in an orbit of their own." So again, if there's a lot of subtlety in here, and subhanallah, as you learn more, you start to see the insight in these verses as well. So it is not for the sun or the moon to catch up. So there's a certain rhythm, a certain structure that Allah has put to the universe, and when Allah says each is traveling in an orbit of their own. So if you think about that, the moon, as we know, orbits the earth. The earth, as we know, orbits the sun. But the sun is also orbiting something, and that is the center of our galaxy. We are on what is called a barred spiral galaxy. Our galaxy has arms, and these arms are moving around in a circular pattern around the center of our galaxy. So the Earth, so the sun, is also in orbit as well. And from a very grand scale, we have massive galaxies and clusters of galaxies, which are in essence tied to each other with gravitational forces and in some way orbiting each other as well. So it's not just the sun and the moon that is referred to here. Each of these objects is in motion. And finally, we have a reference to sun, moon, and constellations. Blessed is the one who has placed constellations in the sky, as well as a radiant lamp and a luminous moon. And the subtlety here, again, is that when Allah refers to the sun, He refers to it in a way which it says it's the source of light. It's a radiant lamp. And the subtlety in the moon description is that it doesn't have its own light. And that's exactly what it is, where we have the sun radiating the light and the heat and the energy, and the moon reflecting that light because of its the ashen color of the moon. And that is the only reason that we can see the moon, because it does not have its own light. So these and other verses contributed to a desire amongst the Muslims to understand the universe around them. And rulers such as Al-Ma'mun encouraged this learning with large grants, leading to the flourishing of research and intellectual progress in astronomy and in other disciplines as well. So I don't know how many, most Muslims, 99.9%, don't know that there are actually 24 craters on the moon which are named after famous Muslims, both astronomers and other luminaries in their fields. If you look here, you have the great traveler Ibn Battuta, who, if you read his works, it's astonishing how he lived his life and where he traveled around the world, preserving the cultures of various different peoples as he traveled in his notes. Then you have these two astronomers that we're going to be talking about today. Al-Sufi, who is actually memorialized as Azofi. Some of these names, a lot of them actually, were Latinized when they came to Europe, and then the translation kind of changed them slightly. And we'll be talking about Al-Biruni as well, whose crater is at the top of the moon. And the Khalifa that I mentioned, the Abbasid Khalifa, Al-Ma'mun, he is memorialized here as well as Al-Manan. So this is something to be proud of as well, that we have so many craters on the moon which are Muslim named, but it's also something that we should reflect upon, that it took the non-Muslims to recognize the Muslims and put them on the moon here as well. And a lot of Muslims don't even know about that. So it's important that we learn about these great luminaries that came and understand their significance to the contributions that they made in their respective fields. So let's talk about Al-Sufi. His full name was Abdurrahman ibn Umar al-Sufi, and he lived about 1,000 years ago. As I mentioned, his name is also translated as Azofi. So he was born in current-day Iran, so he was a Persian astronomer. And most of the Arabic names of the stars that we use, there's 210 that I referred to, come from his book, Kitab Suwar al-Kawakib al-Thabita, which means the book of constellations of the fixed stars. And again, published just over 1,000 years ago. Al-Sufi was the first astronomer to observed the Andromeda galaxy, although he didn't know that it was a galaxy. He noticed it as a cloud in the sky, and he made note of it in his records. And that's the first time that it has been written down that this galaxy was noted in records. And we'll return to Andromeda later on in the presentation. And he also observed the large Magellanic Cloud, which is it's a satellite galaxy of our own galaxy. It's a small galaxy which is circling our galaxy, which will eventually be absorbed by the Milky Way. And we can't see it from the northern hemisphere, but from the southern hemisphere, equator on downwards, it looks like a cloud in the sky as well. A bigger cloud, much bigger cloud than the Andromeda galaxy, because Andromeda is much further away. So, as I mentioned, both the crater Azophi and an asteroid, this time Al-Sufi, they got the name right, are named after him. And as you can see, some of the names of the stars are listed here. There's one star called Fomal Hut. So if you didn't know that it was Arabic in nature, you would think this is some type of German name or German car. But it comes from Fam al-Hut, which is the mouth of the fish. And Al-Anf is the star, it's a famous star in the flying horse called Pegasus. And Al-Anf means the nose. And this is actually the part of the constellation which represents the head and the nose. This is exactly where the star is positioned. So you may hear some of these star names, but they are actually 210, as I mentioned, are from Arabic names as well. And some of these names have actually found their way into popular culture. So I don't know if there are any movie files here, but this movie, Batman Begins, was released back in about 2005. I don't know if anybody, if you remember this movie. It was a great movie for those who like this genre. And in the movie, there was this one actor, Liam Neeson, as those that know. He represented the key villain in this movie, and his name was Ra's al Ghul. And he was the leader of a group called the League of Shadows. For those that know anything about Batman, um, Bruce Wayne in his younger years trained with the League of Shadows. He learned their techniques in terms of fighting and whatnot, but then he left them because they were evil in terms of their philosophy. So Ra's al Ghul is the key villain here, and his name is actually from a star in the catalog of Al-Sufi, and it's from Al-Ghul, which means Al-Ghul, and the full name is Ra'is al-Ghul, the head of the demon, of the ogre. So even in Halloween, you have ghouls and goblins. The word ghoul is from Arabic. It's from the star as well. Al-Ghul means a demon or a goblin. So even in popular culture, it's made its way here. And that's a perfect name for this villain too, because he was the head of this organization, which was doing all this, I guess, fitna and destruction. And the second one is this movie called Beetlejuice. Now, this first movie came out about 20 years ago. Apparently, it was very good. I never saw it. And the second version came out last year, I believe. And from what I hear, it wasn't that great. But Michael Keaton was the actor here, who was the first Batman many, many years ago. But let's not go there. And we go back to Beetlejuice. Beetlejuice is actually the name. It comes from Yad al-Jawza, which means Yad means hand in Arabic, and it's the hand of the constellation of Orion. And it can be also translated as hand of the giant. So in the translation from the Muslim world to Europe, the ya here became a ga, a jim sounding word, and then it went to ba. So that's why you get Beetlejuice, but the origin is Yad al-Jawza. So these are just two examples of ways that these names and the Muslim-oriented names or Muslim-originated names have found their way into popular culture that we would not even consider or even think about that these have Muslim origins. So let's talk about Abu Rayhan al-Biruni. He was born in present-day Uzbekistan, and he distinguished himself in multiple disciplines. And you'll see that about a lot of these scholars and these luminaries in the past, they were not experts in just one field. They were experts in multiple fields. And al-Biruni was a master of physics, mathematics, astronomy, history, anthropology, pharmacology, and there's a bunch more beyond this. And he wrote 146 books in his lifetime, over 90 of which were astronomy related or related to mathematics. So when people say today, I don't have time to do this, I don't have time, he made the time. And 146 of these books, this is not light reading either. He knew and he went into detail about each one of these topics that he covered. And he's renowned for being the first one to measure the radius of the Earth with a high degree of accuracy. And this is incredible because, again, we're talking about 1,000 years ago. And how he did this was he climbed on a hill in what is present-day Punjab in Pakistan. And using trigonometry and algebra, simple math, well, not simple, but math, he measured the dip to the horizon from where he was standing. So he knew how high the hill was. He knew the distance to the horizon roughly. And using math, he measured the angles, he measured the distance, and he came to a number of 3,928.77 miles. And if we look at the current number using the modern technology, we have 3,847 miles. So 1,000 years ago, by standing on a hill and using math, he was within 100 miles of the radius of the Earth, which is astonishing. And just like Al-Sufi, both a crater, Al-Biruni, as I showed you on top of the moon there, and an asteroid are named after him. So in summary, in terms of Islamic contributions, Islamic astronomers in the Muslim world preserved the knowledge from the Greeks and the Romans from before them and expanded it immensely and greatly advanced the knowledge of the stars and the constellations. With Al-Sufi's book, they preserved, because Europe was in the Dark Ages. Remember, Europe was 900 years where all learning was stopped, basically. And for 900 years, that learning, the Muslims took it, refined it. There were many errors that were in some of the books from Plato. There's one book called Al-Majest, which was the seminal work by the Greeks. The Muslims took this work, found the errors within the work, and expanded it to the point where they could, again, calculate celestial bodies, as I mentioned here, with catalogs, observatories, and astronomical instruments such as the astrolabe. They were able to create models where they could predict in the future when an eclipse would occur, a solar eclipse, a lunar eclipse. They knew in 5 years, for example, where Jupiter would be in the sky versus where Venus would be. So these models helped them to advance the study of astronomy by leaps and bounds. And once this knowledge spread back into Europe, after the Crusades and the contact with the Muslims, it led to a rebirth of mathematical-based astronomy in Europe. And we today know about, in school, we are taught about Nicholas Copernicus and Tycho Brahe as famous astronomers of the Renaissance who have massive, very large craters named after them on the moon. But in some cases, for example, in Copernicus's case, he took actually word for word the theories of Muslim astronomers, one particular Muslim astronomer, and he copied them basically to form the basis of his theories. Now, he expanded upon these theories and led to what's called a heliocentric model of the solar system. But there are instances where you can see that he made an error in copying the actual calculations of the Muslims, of the Muslim astronomers, and that error was not found until led to additional errors, and only when he went back and fixed that error by the re-examining what it actually was he able to move forward. So there was a lot of plagiarism there. I would hesitate to say they did accomplish a lot on their own, but the contributions of the Muslim astronomers are not well known or well publicized. And as they say, there's a saying that the only reason I can see so far is because I stand on the shoulders of giants. Well, these astronomers stood on the shoulders of Muslim giants. And it's important that we as Muslims learn this, understand this, and remind ourselves and learn these theories as well, because this is part of our Islamic heritage. Okay, so let's start talking about moon sighting. So what's the current state of moon sighting right now? We have various jokes about moon sighting, moon wars coming to a mosque near you. We have dubious sightings in parts of the world. And then there's this tug of war in terms of which day is it? Is it a Friday? Is it a Saturday? And there's a lot of confusion at times. And then some people get a little creative and invent their own moons as well and claim that they've sighted the moon. But in actuality, it's not that complicated. It's important, as I mentioned earlier, that we understand the mechanics of what does it mean when we talk about calculations, and what does it mean when we talk about hilal sightings, and what is possible and what is not possible. So let's start with the basics here. You have the sun without the face, and you have the moon, as I mentioned earlier, orbiting the earth, and the earth orbits the sun. So when the moon is on the far side, you get a full moon because the light of the sun is shining on the moon and you get it fully illuminated. Now, when the moon falls between the sun and the earth, you have a new moon. So you cannot see the moon at that time because of the brightness of the sun. Only when the moon starts to move away in its orbit do you start to see a section of the moon being illuminated. And that, of course, is the hilal. Now, going back, the moon, the sun, and the earth are not directly on a straight line. And if all three bodies were on a straight line, you would have an eclipse every single month because the moon would block out the sun. But what we have is a tilt. There's a bunch of tilts. So the moon is inclined about 5 degrees above the plane of the Earth's orbit, which is why you don't have the eclipses. The moon will either be above or it will be below the plane of the Earth. So it's not fully blocked out. Only 2 times in a year, when the moon crosses the plane of the Earth, will you have an eclipse. So you would have eclipses twice in a year in one part of the world. And the Earth is also tilted about 24 degrees as well. And this is the reason why we have seasons. So the tilt of the Earth plays a factor into where we're not getting a solar eclipse all the time, and the plane of the moon and the Earth inclination, the moon's orbit inclined to the Earth plane by about 5 degrees. So we have the basics here in terms of what we're seeing here. Now, crescent visibility. As I mentioned, when the moon is in between the sun and the earth, you cannot see anything because the sun is so bright. As the moon starts to move in its orbit away from the central line, you get to start to see a little bit of the moon. Each component or each movement away from the sun is mapped in terms of degrees. It's measured in degrees. And this term is called elongation. So the greater the elongation over here, the less elongation when it's straight in a straight one line here. Now, here's an example of what I was talking about earlier. If this man here was standing right in front of this car, you would not be able to see any portion of the person because the blinding light of the headlights would obscure this person. But as this person moves to the side, you start to see the silhouette, the illuminated silhouette. So this is the hilal that we see after the new moon. So let's get into it now. Now we have the basics. Let's talk about what this translates into calculation methodology starting off with. So at sunset, based upon calculation methodology, which some masajids have adopted here, the elongation, which is the movement away from that central line, has to be at least 8 degrees. So the calculation methodology basically states that if this is 8 degrees or greater, then there's a probability of seeing the crescent of the hilal. So the elongation has to be 8 degrees, and the height of the moon away from when the sun sets has to be at least 5 degrees above the horizon. And this all has to occur before the next day starts. So the international date line is here. This is one day, this is the other day. So all of this after new moon, these conditions have to be met before the next day starts. So here comes Ramadan, coming up now in 2025. And alhamdulillah, I'm pleased to announce when Ramadan starts, we should be in agreement both in terms of calculation methodology and moon sighting. So it doesn't happen all the time, but this time, alhamdulillah, it's a clear-cut case where we should be starting on the same day. And that's because the moon is born way out here just after the new day starts on February 28th. It's born at 12:44 Universal Time, which is right over Indonesia here. Now, it takes certain amount of time for the moon to move 8 degrees away from the center line. And roughly calculated, that occurs over Africa here. This is what this line represents. So before this line, you will not be able to see any crescent based upon calculation methodology. After this line, and because it occurs before the international date line, the next day will be the first of Ramadan. So February 28th is when this moon is born. This occurs well before the international date line, and the first of Ramadan this year, according to calculation methodology, will be March the 1st. And this is an image simulation from Cooper City there, that where actually, because the moon has been so far just before the day started, by the time it gets to Florida and even Mississauga, Toronto here, which we are in the same time zone, we should have in much more than 8 degrees separation. So what we see here is at sunset, we're going to have 11 degrees of separation between the sun and the moon, which makes it very easy to sight, or actually to meet the criteria. And it actually will be not 5 degrees, it'll be about 11 degrees above the horizon. Now, this it's not the case all the time. The position of the moon here makes it easier. As you can see, the moon is directly above the sun here when it's going to set for this Ramadan. Occasionally, what happens is the moon is 11 degrees away, but it would be somewhere around here. So it would set much faster, and that would be the window of seeing the crescent, if you're going by moon sighting, would be much less. So calculation, we're starting on March the 1st. Now, let's get into to moon sighting. Now, this is important. Now, this is very important when we get into sightings that are claims of sightings. The record of sighting a moon, a hilal, with no optical aid, just with your eyes, is 15 hours and 32 minutes, seen in May 1999 by a man named Stephen James O'Meara. He was an amateur astronomer. 15 hours is what is the record time. And with a telescope or binoculars, the record time to see a moon is 11 hours and 42 minutes after new moon. And that was by this brother Mohsen Mirasid in 2002, where he saw it in Kerman, Iran. Now, when we get moon sightings claims, these should be our guardrails in terms of what is or is not possible. And this is something that I will be working with as many masajid as possible to try to implement, because this is important to let us know if a sighting is valid or not. So, as I mentioned before, new moon occurs out here in Indonesia. And these, if you look at the bottom here, these are the time zones. So we have 15 hours or 11 and a half hours. So if we count from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, about 17 hours. So we're looking at a 17-hour-old moon, which is more than enough for us to visually see it. As you saw in the previous slide as well, it'll be 11 degrees above the horizon, so we'll have plenty of opportunity to see it. It'll stay in the sky longer, and it'll be over 1% illuminated. So for us, for those that follow moon sighting, Ramadan will begin also on March the 1st, inshallah, because this is well before the international date line, and it's easy to see, basically. Now, the story for Eid al-Fitr is a different story. So the moon is not born over here. The moon is actually born over Africa. about 10:57 Universal Time. So, according to calculation methodology, remember, it has to be 8 degrees away from the sun, center line, and 5 degrees at sunset. That occurs about here off the west coast of the US. So, according to calculation methodology, the next day should be the start of the next month, Shawwal. So, for them, March 29th is the last day of Ramadan, and March 30th will be Eid. Now, for us, or for those who follow moon sighting, I don't want to say us, there are many different, I guess, philosophies, and that's fine. Moon sighting will be very difficult at the edge of in California because again the moon is above the sun and the configuration right now. There is a slight possibility, but if you count from here, 1, 2, 3, 4, 5, 6, 7. So for eastern coast, it will not be visible. 7, 8, 9, 10, and you may get a sighting here because there's not just the time period, as I mentioned, the position of the moon, the visibility, if it's a cloudy horizon, there's a bunch of factors. So there is a very outside chance that it can be on the 30th as well, but most likely that those that follow moon sighting, the next day will be the 30th of Ramadan, and so you'll have to fast an extra day if you're not following calculations. And I would encourage people to follow one or the other and not to switch based upon the moon sighting or the lack of moon sighting. So it's important to also note, though, that it will not be possible to sight the moon in the Gulf area. So if there is, and there have been in the past, unfortunately, claims where the moon was born out here somewhere or over India, Pakistan, for example, and it was claimed to have been sighted in the Middle East. And it's all what I've told you previously in terms of these guidelines. It's important to use these guidelines as guidelines to say this is not possible physically. The laws of physics cannot be broken by a sighting so close to the new moon. The moon needs time, a certain set amount of time to move out from that center line to be visible. So any sightings that occur less than 11 hours should be taken with a grain of salt. And the other thing is, we live in a time where everybody has a cell phone. Everybody has a camera on their cell phone, or they have DSLRs or SLRs. They have the ability to take a picture. So it's important that if we get to the point where about 11 and a half hours, maybe even 10 and a half hours, that a moon sighting claim comes in, at that point we should enforce a proof, a dalil. You should basically say, show us a proof in terms of a picture. That's my personal belief based upon what I've seen in the past. I think it's important that we are a factual, science-based community as well. That's why we excelled so much in our past. And it's important we go back to that as well. So these are the laws that Allah has enshrined in terms of the planetary motion, the motion of the moon, the motion of the earth, the motion of the sun. And we should use these for our estimation. So if you're following calculations, you have your criteria. For those that follow moon sighting, these are the criteria that you should follow in terms of what is and is not a legitimate sighting of the moon. So I hope that's clear. And at the end, we can talk about, if you have any questions, please do let me know. And Brother Riyadh said we will be sending out this presentation so you can have this as reference material afterwards. So for the last part of this presentation, I want to go into what is visible right now in the sky. And this, again, is taken from the perspective of Cooper City, but this is also here in Toronto. It's very accurate in terms of what we can see right now. So from this representation, what you can see is we have Saturn. This is about 7 o'clock, almost 7:15 at night. We have Saturn in the sky, which is about to set. We have Venus, which is a very bright star-like object in the western sky. And above here, we have Jupiter. Jupiter is almost directly south. It's not as bright as Venus, but it is a fairly bright star up here. And actually, just to the northwest of Venus is the planet Neptune, which is a blue gas giant, but you need a telescope to see that because it's very faint. And just to the west of Jupiter is also the green gas giant Uranus as well. So you have 1, 2, 3, 4, 5, and then finally we have Mars here as well. So we have 6 planets visible in our sky right now. This doesn't happen very often. There was a lot of media hoopla about the planets lining up in one line, and we can see them all on January 25th. That's a lot of overspun hype. The planets are not lined up, but we can see 6 of them in the sky at one time, and it doesn't happen from one date. It happens because planets and they move in their orbits very slowly. Some of them. This will be the case for the next couple of weeks at least. So it's been the case since January, and it will be the case. So, and you can see some of the planets. For example, Mars. When you look at Mars, it does appear quite red actually. So one of the objects I want to talk about, if you go back, is this constellation Orion. There's the star where we talked about earlier, Betelgeuse, Joza, and you have a star here called Rigel, which is Rigel, which means the leg, and you can see this is called Orion the Hunter because you can see the 3 stars of the belt. These 2 stars form the shoulder, and these 2 stars form the bottom of the tunic. So Orion the Hunter is this famous constellation in the wintertime for Northern Hemisphere observers. And surrounding this constellation is enormous clouds of hydrogen. It's called the Orion Molecular Complex. But these are very faint to the eye. You can't really see them at all, actually, because they're very far away. And the light doesn't travel that far. And these are the remnants of ancient stars which exploded, and hydrogen is the most plentiful gas or element in the universe. Now, we can't see them with the eye, but I recently took a picture of Orion with a camera which was modified and is sensitive to hydrogen, and I put a special filter in there. And this is what Orion looks like in that, using that filter. Look at that. Look at the clouds of hydrogen which are forming or which are formed around this area. This you can see is called Barnard's Loop. And what astronomers speculate is that there was a star which exploded eons ago, millennia ago, and that this is the shock wave of the parts of the star that exploded this way. There's multiple theories, but that's one of the theories that is circulated or postulated. So this was taken in Alberta with the Rocky Mountains below. And in the middle, particularly, is this object here. And this is called the Orion Nebula. And the Orion Nebula, when you zoom in on it, as this next picture will show, is a birthplace of stars. I took this picture from my backyard, actually, about in December. And this is a stellar nursery. And stars are being born inside this cloud complex. And you see the hydrogen as it turns up into red, and the bluish areas are actually oxygen. So the filter that I use is sensitive to hydrogen and oxygen. And this massive complex, you can actually see it with your eye if you don't look directly at Orion. This is remember the 3 belt stars. This is what's called the Sword of Orion. So if you look in this part of Orion, if it's clear tonight in Cooper City, I'd encourage you to go out and take a look. Tonight here in Mississauga, we are actually having a snowstorm. So I might do this next time in person in Florida. But you can see this with your unaided eye. So take a look at this. And one of the key aspects of this that I want to emphasize is these stars, as I mentioned here, are about 1,500 light years away. So the light left the star, as you look at it, 1,500 years ago. Think about that. It's been traveling for that long. Excuse me. And that's significant because if you think about it, some of this light, not every single star is exactly 1,500 light years away. There's variances here. But some of this light that has left this constellation or left these stars around the Orion Nebula left the star when the Prophet ﷺ was walking on this earth. So think about that. When his blessed presence was on this earth, that star shone that light out. And when you look at this star, that photon of light is hitting your eye. It left and it's been traveling since he, sallallahu alaihi wasallam, was walking on this earth, and now you are seeing it in real time, basically, as you look at this star. So that shows you the distances that are involved here, and it really shows you the time and space relationship, and also how briefly you are on this earth, 70, 80 years, while this light has been traveling for that long. And this is not even close to the longest or the furthest object that we can observe. Something to think about. So Jupiter is the next object. As I told you, due south, straight up, you'll see a bright star, and that's Jupiter. It's the largest planet. 1,300 Earths can fit inside. And as I mentioned, this is the Great Red Spot. It's a storm that's been at least 350, 400 years. We've observed it, probably older than that. And 1.5 Earths can fit inside. Opposition is when a planet, every year, each planet becomes the closest to Earth when our orbits align. And that occurred on December 7th for Jupiter. So it's still pretty bright. It was closest on that date, but it's still pretty bright right now. And it's receding away as the Earth and Jupiter move away in their respective orbits. So it's still very high and bright in the sky. And the 4 brightest moons are visible. These are called the Galilean moons because Galileo Galilei, the European astronomer, was the first to document them. So the 4, and as you watch these moons over a couple of hours, you can actually see them moving in their orbit. So you can see them change positions as you observe over a couple of hours. Now I took this image. These are the set of images over about an hour or so, between half an hour to an hour. And you can actually see the rotation of the planet. And this is the moon Io, and it's casting its shadow onto Jupiter. So this is the amount of motion that the planet is exhibiting within about half an hour to an hour. I took about 25, 30 images, and I strung them together in a GIF format to show the actual planetary motion. And again, this is from my backyard. You don't have to go very far. You can just, in the middle of a light polluted city, you can see the planets because they're so bright. So you don't have to go into the wilderness to try to, take a picture of these planets. I know there's a lot of crocodiles out in Florida, so it's not worth risking your life and limb for this. Mars. So Mars is roughly half the size of the Earth, and it is known as the red planet because of all this. It's basically rust that is on the surface of the planet. It used to have an atmosphere. It used to have oceans, but because it's so small, it lost all of this in the water, and the radiation irradiated the surface and turned the surface to rust, basically. Now, it just had its opposition, so it's still very bright in the sky. And because it's much smaller, but it's closer than Jupiter, it appears fairly bright. But and you can actually see with a small telescope the polar cap. So this is the polar cap on Mars. There's very little snow. It's mostly made out of dry ice, actually. So as it gets closer to the sun opposition, this polar cap actually melts and shrinks quite a bit. It doesn't go away, but the further it is, the bigger the polar cap is. There are 9 missions that are currently operational from a variety of nations on Mars right now. The Curiosity rover, the Perseverance rover, and the Emirates actually has an orbiter orbiting Mars called HOPE, and this is actually studying Martian weather. And on this image that I took in December, you can actually see some of these clouds here. There's these bluish ice clouds that appear. And the biggest volcano in the solar system is just off the rim here, called Olympus Mons. And a lot of times clouds appear around the top of that volcano as well. So then we're looking finally at the Andromeda Galaxy. Now, as I mentioned, Al-Sufi was one of the first ones to note that this was an object in the sky. And if you look northwest, around this is about just almost 10 o'clock at night, you probably have to go out of the city for this because the light pollution washes this away and it's faint. And a lot of the times you have to look at it not directly, but with averted vision. So you don't look directly at it, you look at the side of your eye, and you can start to pick out the fuzzy patch there. Now, this is the Andromeda Galaxy. Now, Al-Sufi in his book noted, and this is again the first instance of an astronomer actually noting it. So if you look here, you have three stars lined up here. One, this is how you find Andromeda. Bright star, second bright, third, and this is just off this. In Al-Sufi's illustrations, these are these stars. You have one star here, the bright star, the second star, the third star, and at the nose of this fish-like creature, he noted that there was something there in terms of a cloud-like object. And that's the first documented case or instance of the Andromeda galaxy being noted in a manuscript. So this is what the Andromeda galaxy looks like. This is the picture I took over several sessions, both with a hydrogen alpha filter to show the nebulae in the spiral arms of Andromeda and the actual structure of the galaxy and its arms in normal light, in RGB as they call. Andromeda has about 1 trillion stars in this galaxy. It's a massive galaxy. And it is actually 2.537 million light years away. So remember when I told you about the Orion Nebula? It took 1,500 light years to travel. This light, when you look at it, has been traveling for 2.5 million years. So we're looking at this galaxy as it was 2.5 million years ago. And this is the closest galaxy to us. Think about that. So the other thing is, the closest galaxy to us is speeding towards us at a speed of 110 kilometers per second. This galaxy will basically eat our galaxy. There's going to be a collision of galaxies, but you don't have to worry about it. It's about 3.5 billion years away. They're actually saying that the galaxies themselves have a huge complex of stars that we can't really see visually, but they're actually touching already. That's how far out. So the aura of galaxies, this halo of stars of galaxies extends, and this is just a very, very recent discovery, extends way beyond what we can see. And the halo of the Milky Way and the halo of Andromeda have already started to touch. But it takes a speed of 110 kilometers per second, not per hour, per second. It's speeding towards, and it's going to still take 3.5 billion years to get here. So in conclusion, one of the things I also wanted to tell you is that I've been doing this for many years. And I find that when I go and I look at these objects, it's a very deeply spiritual experience for me. Because you see, there are times even when, a seasoned astrophotographer, I look through my telescope and it's just amazing. It's awe-inspiring that what I'm looking at. And I have to step back and say, Subhanallah. And I praise Allah for allowing me to see these objects and understand what they are. And you really do get what's called a transparency of your heart, where you say, you know, Allah, you have created this not in vain. And Allah truly is the light of the heavens and the earth. Allahu nuru samawati wal ard. And you really feel that when you step outside into the night sky with a telescope or even without. And the key here is, for me, is that the power that you see in the universe, the forces that you see in the universe, the beauty that you see in the universe is a hint of the beauty and the power and the magnificence of the creator of the universe, Allahu Azza wa Jal. So thank you very much for listening. And again, I'm on social media, Unshakable Astro. Please do like, follow, and subscribe. It helps to allow me to do more programs and get the word out, inshallah, to the Muslim community and beyond. Jazakallah khair.